everyone, and welcome to the Data Science Salon YouTube channel, the go-to resource for data science managers and practitioners who want to acquire new skills. In 2009, author and motivational speaker Simon Sinek delivered the non-classic TED Talk, Start With Why. Viewed by over 28 million people, Start With Why is the third most popular TED Talk of all time, and it teaches us that great leaders and companies inspire us to take action by focusing on the why over the what and the how. In this presentation, Jessica Stauth, Managing Director at Fidelity Labs, will talk about how applied data and computational scientists can use the power of why to frame problems, inspire others, and give them answers to business questions they might never think of asking.
Hi, I am Jessica Stauth. I'm a managing director in Fidelity Labs, which is a corporate innovation group inside of Fidelity Investments. And today I'm going to be giving a presentation, a talk titled Start With Why. It's not just good leadership advice. Understanding and framing problems for applied data science wins. So what I wanted to do with this talk was to really take a huge step back in sort of applied data science and really look at this foundational question about starting with why. And I am referencing, maybe some of you may have come across a TED Talk from Simon Sinek, the third most watched TED Talk of all time, which is called Start With Why. And one of the great quotes that Simon has in his presentation is that people don't buy what you do, they buy why you do it. And I'm going to talk about how asking why and thinking about why is, in my view, so central to doing good data science work. But I did feel that the business management domain was a little squishy for a data science talk. So I wanted to add one more science-focused quote to motivate this talk, which is from Ben Franklin. All highly competent people are looking for ways to grow, learn, improve. They do that by asking why. And this is the part I like. The person who knows how will always have a job, but the person who knows why will always be the boss. And I think that is a thought I want you to keep in mind as we go through this talk. How can you, as a data scientist, always remember and start with thinking about why you're doing the work that you're doing, what is motivating it, and that's really going to lead you in the long run to the best work, most impactful work. All right. So before I dive into sort of talking about my broad data science why topic, I wanted to give just a little bit of a tour of my own history of the years I have spent asking why. Also, of course, with some laborious work on learning how. So my background and what you'll see informs this talk a lot. It comes from a basic science background. So I spent 5 years at Berkeley doing a PhD in a biophysics program. What I loved about that program was that I was really indecisive as a grad student, and I didn't know exactly what niche of science I wanted to sit in. And the biophysics program at Berkeley allows you to really scan and look across just about almost any hard science lab and think about what you wanted to do. I ended up working in a computational neuroscience lab where, later I would realize I learned some foundational skills, coding in MATLAB, really principally, but really a lot of thinking about asking questions and trying to think about how to formulate questions in the basic science world. So from that background, I really wanted to move into applied science, and I was able to do that and really fortunate to join a whole group of folks just like me who were coming from the basic science background into thinking about how to apply our sort of hypothesis-driven research mindset and our analytic skills into something practical, and that ended up being stock market prediction. So I went to work for a company called Starmine, which is a company that had later been bought by Thomson Reuters. But what I did there was to go from thinking about models that would describe and predict behavior in the human brain and sort of how we might perceive the real world and respond, into thinking about, well, what are models that would represent how a whole collection of people together making buy and sell decisions, which is really what the stock market is. How would I think about organizing and modeling that type of information? So I was there for a couple of years. Actually, that company, like I mentioned, got bought by Thomson Reuters, stayed on for a few more years there. And I turned from just a really narrow research focus on thinking about how do I build models to sort stocks based on their predicted future change in price over the next 30 days. That's how narrow that was. How do I think about this a little bit more broadly and the whole universe of investment professionals who might buy research data and analytics tools from Thomson Reuters? So that opened my lens up a little bit bigger. From there, I moved from the West Coast back to the East Coast, and I came across a really exciting company back in 2013 called Quantopian. Quantopian was a company where we wanted to figure out if we could democratize access to data and tools in this quantitative finance space. I really had a chance there to actually get a lot broader lens on what we all call data science now, because Quantopian had a public-facing website, and anyone on the internet could sign up for an account for free and start writing code against a bunch of stock market data. So I would definitely say that later phase of my career, I was able to see a lot of how other data scientists who had gone into areas outside of just stock market modeling had developed their skill sets and what they might have to add back into that domain. And then finally, today I mentioned I'm at a corporate innovation group inside of Fidelity, and our mandate is to think about how to build new fintech businesses for Fidelity. So that's been a really exciting road, and hopefully I'll touch a little bit on some of the lessons that I've learned, various stops along this journey that have taught me about asking why and a little bit about how. So I want to move through this a little bit quickly because I think you'll sort of get the gist from that path that I just described. But I think it's important to sort of keep in mind, as a lot of us come from different scientific backgrounds, what are those foundational differences between basic and applied science, right? So basic science has a very specific goal, which is to advance fundamental knowledge about the world. Right? You're going to do original research. It's really difficult. The insights that you generate may or may not have readily observable applications, right? So if you learn something new about the world and it's not immediately clear how to apply it, in basic science, that is okay. In applied data science, though, our goal is to generate insights, and not just for the sake of generating insights. Those insights need to be used by someone, maybe us with a different hat on, but likely an analyst or a business user, and they need to be translated into tangible business value. Okay, so the insights are really as valuable as the business value that they drive. Now, I would argue that these two sides of the coin are getting a little bit more iterative and overlapping. And if you look at how quickly things have been advancing in the machine learning space, and some of the technologies that are really being sort of developed and utilized in extremely tight iterative loops, I would argue that it's getting more and more the case that you can indeed be learning new things that you aren't sure where they apply yet and readily applying them. But nonetheless, I think it's really important to keep those two things in mind. So we're talking today about applied data science. That means that for everything that we do and everything that we think about, we need to understand that business value is the why statement for us. So that's easy to say. What are some examples of business value? And you need to know what that business value is as you're building your model and as you're thinking about where it fits in. So when I was at Quantopian, we had a really simple value proposition. We were looking to make predictions about investment returns and figure out in our trading algorithms, which companies should we be buying, which companies should we be selling. If you're working for a company that is trying to sell something other than an investment product, then you might be thinking about how to drive sales of your product. An example I like to add in here is you might be working at a company like, for example, Zappos, as an example I like to use, where really your whole foundational thinking is around driving customer happiness. If you've got a business value that's something a little bit intangible like customer happiness, you're going to need to work backwards and think of some tangible intermediaries that you can use as proxy for having your customers be happy, which is always a great goal. But I want to touch on a couple of other business values that are incredibly important and maybe not coming to mind as readily. So operating efficiency, making a process cheaper to do. Now that could be anything from automating something that used to go to a call center, routing calls more efficiently, from making connections and utilizing less compute resources, right? Any type of a value chain process that your company might employ, almost always with enough effort, you can find somewhere along that chain to make things more efficient. So that's the efficiency play. Speed to market. Do you have an opportunity where your company might be looking to launch a new product, and what you want to do is get there quickly, throw something together, get it out into the market. And then lastly, user engagement. I think that is a business value that we've all seen take hold over the last, maybe 10 plus years. And it's also one that I like to include as an example because we've all seen how risky it can be to purely optimize on user engagement. And it's one I think that we're going to see a lot of careful thought around in the next 5 or 10 years. All right, so now let's say we've hopefully selected one of those business values and we know what our why statement is. I might say, let's say we've picked, we're looking to sell a product or make a customer happy, but let's say product sales. Now you need to understand what are the set of insights that your model or your data science work is going to be creating. And some examples I put up here are, it might be a next best action. So maybe we're looking to increase our sales by increasing the efficiency of a sales force of folks who are actually taking actions and trying to sell a product. Then we might want to build a system for our sales team that will tell them, without them having to guess and think about it, what their next best action in a sales process might be. We might not have a sales force. We might be working on a product that is sold online. Then we might want to be making product recommendations in a user experience for our customer. So you could think about Amazon is recommending products for me, right? And then lastly, one that I've actually worked a little bit thinking about in labs is, what about trying to model the probability that someone's going to make a purchase? So if you're thinking about selling a product and having a fixed budget for how you might advertise that product, you might want to try to understand ahead of time, before you pay to put ads in front of folks on the internet, hey, who are people that are predisposed to want to purchase my product? So can I create a model that might predict the probability of purchase and aim my advertising dollars in a specific way? Now, next critical step that I have seen missed is, all right, so I know my why statement. I know what my business value is. I know the type of insight that I'm going to create to drive that value. Can the business users understand and capitalize on those insights that I've created? Sounds easy, but some really nice questions to ask yourself to sort of verify that that's likely to be the case. Sounds very silly. Does it make sense? Does the insight that you found fit with your understanding of the broader landscape? And if it doesn't, this is a great opportunity to look really closely at your model and try to make sure that you really understand why the insight came out the way it did. If you've got a result that's not that sensible, you want to go back up the pipeline. Again, it sounds really easy to say, but I've seen really smart, highly credentialed data scientists sort of come down and say, well, I found this, so I think here's the insight we need to move forward. And you say, well, does that really fit with what we expected to see? Great question to ask. Now, is it valuable? Ideally, when you've designed the insight that you're going to build for, you're hopefully targeting that insight so that when you know an answer, it will be valuable. But often data science is a nonlinear pursuit, and we are iteratively trying to figure out what insights to create. And someone may hand you a data set and they may not know exactly what conclusion or question they're looking. So if you're doing a bit of exploratory work and you're finding some insights, you want to make sure that you go back and say, okay, but are these really of value? Is this time to push forward, or should I keep working? And then is it easy to use? This is an example where I think what I'm thinking about here is, let's say you've created a dashboard. Is that dashboard something that's part of your end user's workflow? Can they get at your results? Can they see what you're seeing? Can they refresh or expand your analysis? Is this something where you're generating an insight that's going to be usable? Because if the insight is locked on your own local machine or in a PDF that you're showing folks and no one else can sort of really use that tool, then you're probably going to get limited adoption. If you are able to publish something where other users at your company can tweak things, try out their own versions, consume the output of your work and use it in their day-to-day work downstream of you, oftentimes you'll find really surprising adoption. Now, that can lead to sort of, are you going to support that tool? But making insights in a fashion that other folks can access them and use them, I have found that to be incredibly valuable when I have seen people do that well. All right, so all of that maybe sounds easy. You've found a why statement, an insight, and yes, it's sensible, it's valuable, and you've made it so folks can use it. Great. That sounds doable. I can follow those steps. So what are some ways that this all goes wrong? Well, first, second, and third, data, right? So we're here to talk about data science, and I always like to point out that data is a sort of a love-hate relationship, right, or an approach avoidance relationship. It can't be overstated. 9/10 of your work as a data scientist is going to be finding, cleaning, curating, understanding, care and feeding of your data set. It's not a one-time job. It's an ongoing tending your garden, pruning it, keeping it in good shape. It's just absolutely, the most important part of your work. Now, all of these other aspects are important and places where it's easy to get sidetracked as well. And I've seen work well and be challenging. So let me touch on a couple of those just to keep them front and center. So communication. A lot of times, I think it can be really challenging to have effective communication and collaboration across different types of users and cross-functional teams. And we're all getting more and more comfortable working in small, agile, nimble, cross-functional teams. But there is a lot of opportunity for there to be shorthand, lingo, or jargon that gets used that makes it difficult to translate value across those different verticals. So I think that if you consider your job as a data scientist not simply the construction of a model with a certain set of accuracy or precision or recall or statistics that come out of it, but if you consider your responsibility to traverse that round trip of communicating, understanding the problem, again, right, that framing, understanding the why, the business value, the insight, and then your customer. That's a question I like to ask data scientists a lot when they learn about their work is, well, who do you consider your customer? And your work is not done until your customer has understood and been able to consume and hopefully do something valuable with the output from the model that you've created. Some other common gotchas that I see are speed. So time is the enemy. Often when business users are asking data scientists to create insights, they're looking for a quick turnaround. Now, that can be on a scale that's not reasonable, or it can be on a scale where the data isn't sufficient to answer the question being asked. But often, I think there's a good compromise to be made through communication to really prioritize speed and pace over perfection. So understanding when that trade-off between tweaking your model or your process a little bit more to make it sort of 2% more accurate might take 2 more weeks, versus when you've got something that's good enough, you can ship that, put it into production, and give your business users some answers that they can work with in the meantime. One thing that I think helps when you're looking for speed is to just continue to look for the smallest bite-sized pieces of the problem you're trying to solve, and chunk that work up into phases that ideally have proof points and can be very, very iterative. So I try to usually think about what is the smallest, simplest, almost like most idiot-proof component of the problem that I'm trying to solve, or the insight that I'm trying to deliver. Find that, deliver it, get that round trip where now my business user says, geez, that's what I expected, or I didn't, that's closer, that's less far, that's closer, or that's further away from what I wanted, and iterate. So iteration and small bite-sized pieces is a way to really prioritize speed. I'm putting in here, predictions are hard, especially about the future. There's no better way to learn that than trying to make stock market predictions and make algorithms and models that can generate abnormal returns or outsized returns. But I think it also has lessons for thinking about the types of data models that we can create and deliver value. So I often find that something that's looking to create a forecast, something that's a short horizon forecast is often easier than a middle or longer horizon forecast, right? So what's going to happen tomorrow or in the next few minutes if I know that a user is opening a new window and they might press buy, that's a lot closer to the end point I'm trying to predict than just getting a sample of customer data where I don't even know, what products they might be looking at. So could go on and on about that one. My headline on that one is sort of when you're tackling hard problems, look for the lowest hanging fruit or the easiest version of the problem to solve that's still relevant, and try to start there, and be cautious about making future predictions. Nerd sniping. So it's easy to mix up what you're optimizing on. It's easy to get focused on continually improving, tweaking, and honing model accuracy, and to lose track of the business value delivered. So I've been hammering on that. During this talk, you'll be sick of hearing about that, but it's something that, we are all in this space because we like working on hard problems, and we like figuring out and teasing apart knots in data. And we have to remember that while that's fun, that's actually not what we're being paid to do. And what we're being paid to do is create and deliver business value. And so you have to have a balance and keep that in mind. All right, so where I want to kind of leave this is that in my view, and I think this is great about a lot of folks that come into the data science field from all over, right, inside of academic science, is that really a lot of these gotchas or challenges that I've touched on are things where there are really foundational principles and skills from the basic science discipline that you can bring to bear. And so I had come up, was trying to think like what's the way to capture sort of the set of scientific principles, and actually found some nice examples of sort of scientific thinking principles from sort of high school level education online. And I picked these 6 that I like. So I'm just going to skim through them really quick to leave you with some thinking around how to apply these. So extraordinary claims require extraordinary evidence, right? This sort of goes back to that. Does it make sense? If something doesn't make sense and it's really wild result that comes out of your work, you want to go back to basics and understand, is there a really good reason to believe your result, or is there more reason to question something in your analysis that got you there? Falsifiability. So what makes a claim falsifiable? Can you turn the data backwards and show if you could prove the negative of it? So is there a way to sort of compare? One example we were looking at the other day is, someone wanted to make a statement. Let's take a simple thing like gender. I think men are more likely to buy financial advice than women. And we had a data set where there were more men paying for financial advice than women. Well, if you looked at who wasn't paying for financial advice in that data set, that was also more men than women. There were just more men in the data set, right? So can you show that your claim is falsifiable? Occam's razor. So have you come up with the simplest, most parsimonious theory or model? That's one that's always great to think about when you are justifying going into some complex machine learning or some complex deep learning. Can you prove that you really have to do that? And I like to think of showing really simple benchmarks to compare against to try to answer that. Is your result or your model replicable? So can you be robust to data sources that should be just sort of the next tranche of data? Are there other simpler hypotheses or just other hypotheses that you could disprove? And then a really challenging one, but a good one to keep in mind is, are you being careful about thinking about A causing B, correlation versus causation? Are you finding two things that happen to be aligned in time, but that's just happenstance? So those are all principles that I want to leave you with as you go forward and think about how to apply data science in your daily work, and thinking about hopefully bringing to bear some of these scientific principles as you think about how to add business value and focus on your why statement. So I want to stop there, and I want to thank everyone for listening to my presentation today, and I look forward to fielding some questions and talking live.
Thanks for watching the presentation by Jessica Stauth, Managing Director at Fidelity Labs, about how applied data and computational scientists can use the power of why to frame problems. Thanks everyone for watching, and if you enjoyed this presentation, feel free to share with your team and access it for free on our YouTube channel.